All right. So, moving on to the organic chemistry component of the attractive forces. So, the stuff we just talked about previously ties into organic chemistry because it will explain then which type of equipment you want to use depending on the procedure. I've given you guys this summary sheet because I think it's really, really good, and there's no point in you writing down lots and lots of stuff. If you guys remember in the previous lesson, we talked about conversions from one molecule to another and using that giant flow chart. And one of the things they might ask you with the conversion of one molecule to the next is what equipment do you need for your various steps? So just kind of keep that in mind. Ooh, did I have my giant flow chart with me? Did I put it over there? I think I put it over there. Let me grab it. That way we can actually explain why we need to use different techniques. Okay, this is a random hill here.
Oh, that was mine.
This, what the hell?
Yeah, I did.
Okay, what is it?
I don't know what it is. Mas she's white, it's not even important.
Right, when people do you guys just believe this? I will give it to your bio teacher to sort because I don't want to leave a random film floating around in my classroom.
You're right. I think it's probably the antibiotics. It looks like an antibiotic. All right. Moving on. This is what I'm referring to from Monday's lesson is the flow chart. What? It's in the folder. It's not going to be color-coded. You're going to have to color-code it yourself. I didn't print in color because it costs more money. Oh, the colors are representing the different types of reactions. It's really worthwhile if you were absent on Monday to watch Monday's lesson at some point because it's going to be a meaty question you're going to have to answer. Yeah, and it's also, what was I going to say? It's also going to be what your quiz is on tomorrow. So, all right. With Monday's lesson, we talked about converting from one organic functional group to another. And Nana, Brooklyn, going through the notes now. Okay. So one of the things we have to be mindful of is we need to convert from one molecule to another. And in order to do that, we're going to have to use a variety of different kind of chemicals. Say, for example, concentrated sulfuric acid in order for that to occur. When we are doing these conversions from one molecule to a next, there's going to be different steps that we need to do in order to purify it or to remove things we don't want. So that's what these organic chemistry techniques talk about. Yeah, Klein, you don't need to worry about this. This is organic. So, for example, I like to start with these guys because this is all kind of equipment stuff. The addition of a carbonate. So if you're thinking about your procedure steps and you're adding carbonate to it, remember that carbonate is a base. And we use that in order to neutralize acids. In particular, the things that we're going to want to neutralize in organic chemistry would be things like, I'm just trying to figure out the color. There we go. Things like concentrated sulfuric acid, because we often use that as a catalyst agent. So say, for example, if I'm trying to make an ester, I would be taking a carboxylic acid and an alcohol and putting them together. And in order for that reaction to occur, I need to use concentrated sulfuric acid. Yeah, go for it. Now, after we do this chemical reaction, I'm going to have excess sulfuric acid left over, so I want to get rid of it. So that's why after we do that step, we would add things like carbonate to neutralize it. Or if you are trying to, like I said, make an ester again, you might have unreacted carboxylic acid that you want to get rid of. So again, adding that carbonate will neutralize it. So just be mindful that that's something that we might want to do. The other thing you might want to do is adding the anhydrous salt. This guy is important because what it does is it removes or absorbs water. So really important if we have water as a byproduct. So it's just a way for us to kind of get rid of it. Now we have to remember that this anhydrous salt is a solid. So if I want to purify something and get rid of a solid, we then start using and thinking about the equipment up here. So 4 different bits of equipment we could use. If I have a solid and I want to get rid of the solid from my mixture, I would be using filtering as my process. So filtering is a way that we remove a mixture. So we have a little bit of filter paper here. I pour my liquid into it. And what that's going to do is it's going to catch all the solids, in this case, the salt, and then I will just have my organic liquid coming through. So that would be an instance when I would select that bit of equipment. You okay so far? Keep going? Okay. The next thing we could use to help separate stuff is going to be a separating funnel. Now, this is only going to work if both of the items in my mixture is liquid. So they need to be liquid. The other thing is that we need to have layers. So we need something that's polar and non-polar. So what happens is, it's just like oil and water. You have 2 separate layers. And what you do is, just like in titration, you'd open up the tap, you would let the first layer go through, and then you would close the tap to stop the second layer from going through. And the less dense layer is the one that's on top. The heavier thing's on the bottom. Something that's polar and something that's non-polar if I want to separate it. Are we okay? The last step of separation that I have as a potential choice is distillation. In this case, I don't have the polarities to use as a distinguishing factor. And so what we're going to use here is going to be boiling point. So I separate things based on boiling point, and this is the most accurate way to do this. The thing to remember is that the lowest boiling point will go off first. So we often use this when we're trying to separate aldehydes. So the idea is we can remove the aldehyde before it does the second oxidation step. So let me show you what I mean. Can I move to the flow chart real quick? Nope. Okay. Where do you want me to go down to? That one? Yeah. So we have a base. I'm trying to figure out what color. Like, is that easy to read? I think so. And then do you want the other ones? So filtering removes the solid. This one here separates polar and non-polar. This one here separates based on boiling point. This one's obviously like the gold standard because like boiling point is really specific to the molecule. So we commonly use this in aldehyde productions because when we look at the flow chart, let me just grab that guy. You see how alcohol goes to aldehyde, and then aldehyde forms the carboxylic acid. So what I want to do in aldehyde production is I want to remove it from my reaction, because if I leave it in the test tube, it's going to react further to a carboxylic acid. So if I remove it, it doesn't form a carboxylic acid. And so I remove it here. Now, some things to keep in mind is that the aldehyde comes off first. It won't come off before the alcohol. So if you remember, in the mixture, we're going to have a primary alcohol and an oxidizing agent. And I only want the aldehyde that's being produced. So this is where the stuff we talked about in the first half. An alcohol has the OH, whereas an aldehyde has a C double bond O. So this guy here can form the hydrogen bonds, whereas this guy up here can't. So out of these two guys, the aldehyde would have the lower BP. So that way it would boil off first, and I won't affect the alcohol that's still in my test tube. I'm trying to figure out what the easiest way to see that is. Sorry, I will scan these notes. Do you want me to change the color of my pen? Would that help? Yeah. You think it's just the sun? While you guys are writing, I'll try to change that. Make it better. Better? All right. Yeah, wait. Excellent. Distillation is often your last step whenever you're doing anything, because it's the best way to remove stuff. Watching the time. Okay. So basically, when we're looking at distillation, we heat a lot of our reactions because that speeds up the chemical reaction. Things start to boil, and then it goes down this condensing tube and then chills. So it boils over here, and then it condenses down here. And then this becomes the pure product. And then we often have a thermometer to measure the temperature, because that temperature is really important. If we overshoot the temperature for the boiling point, we're going to start boiling off the second substance. Can I move it? Which one? That one says temperature. This one's condense. So the idea is I have heat for my chemical reaction. The aldehyde will boil off. I read the temperature to make sure I've hit the boiling point of just the aldehyde. If I go past the temperature of the aldehyde boiling point, I start boiling the other stuff like water and the alcohol. It then goes down to this condensing tube where there's cold water running on the outside, and it cools it down so it goes back into the liquid form and drips into a second flask. I'll try to find the equipment for you guys so you guys can see it. All right, keep going. Okay. Last bit of equipment is your refluxing. It's a very similar setup to the distillation setup. The only difference is that instead of it being connected to another flask, there's actually a plug to hold it off. And so what happens is you're heating the chemical reaction. So again, it increases that rate of reaction. It increases our yield. The substance obviously starts to boil because we're heating it up, but with the condensing tube being stopped, it will condense back down into my reaction flask. And that's really important because then it makes sure that we don't lose any of our reactants, so we have a higher yield. So this one we commonly use when we're trying to make ketones and carboxylic acids. Because with the carboxylic acid, I do want for both steps to occur. So I don't want to remove the aldehyde as an intermediate. So just to kind of show you the flow chart. Alcohol to aldehyde. If I wanted to remove the aldehyde, I use distillation. If I wanted to ensure the aldehyde reacts a second time to form the carboxylic acid, I use the reflux tube. So that way the aldehyde, instead of escaping away, comes back down into the reaction flask and reacts again. We also use it a lot for ketones. Again, just to ensure there's 100% reaction. And that's it for the notes. All right, questions, concerns, comments? I'll show you guys what an exam question for this looks like, just so you know. But I'll let you guys have a second to write things down. So I've selected the 2021 exam, but this one's the organic one. And you can see that they have the pictures of the apparatus that we've just talked about. And they're talking about pentan 1-ol, so a primary alcohol can be heated with the potassium permanganate, which is an oxidant. It can form either pentanal, which is our aldehyde, or propanoic acid, which is our carboxylic acid. And so for this question, they want you to answer, like, what is the name of this apparatus? That's distillation. This one's reflux. And the second part of the question, they were asking you, why would you use apparatus 1 to make the aldehyde and apparatus 2 to make the carboxylic acid? So again, just like I was talking about, refluxing versus trying to remove the aldehyde to prevent the second step. Yeah, just wanted to show you again how they asked that question. Organic's kind of tricky because they don't have set categories, so sometimes this comes up, sometimes it doesn't come up. But it's worthwhile to know it just in case. Cool. All right. The organic chemistry kids, just FYI, pages 186 and 189 are really good if you don't feel confident with this material. There's also additional pages that you can do looking at comparison the melting and boiling point. It's not a question I see come up very often, but in case it does, it's worth practicing. And then there's also collated questions on organic techniques as well. So just keep doing various practices. All right, you guys have 10 minutes, so you can pick something to work on.